Good. So they want us to determine two things. The value of the account after 7 years, after she started it. That's my page 7. So part A and part B. When we're asked to find the value, what do I have to do after 7 years? What do I have to do?
That's fine.
So I have to find V of 7. When I'm asked to find the rate of change after 7 years, what am I asked to find?
V prime of 7.
Thank you very much. Thank you, Sammy. Great. That's it. I'm going to punch in the function to get V of 7. Then I have to find V prime of t and then plug in 7. So, am I recording? Yes, I'm recording. Okay, so in y equals, clear everything and punch in 20,000. Oh, no, too much. Times E. No, I didn't mean that. Let me start from scratch because I just messed it up. So 20,000, and I want E. Good. And the power, you know I love parentheses, 0.545 x or t, doesn't matter, and second and table, I plug in 7, done. 29, I want to highlight it just to make sure, 29289.59. And I copy that, 29289.59. Good. Next, I have to find V prime of t. So let's find that here's the function. Can anyone help? So I'm going to copy it here anyway. So this is not a product of two functions. This is not a ratio. This is just a simple function. So let's find V prime of t. The constant stays outside. Don't bother with it, please. It's right here. I need to differentiate this. Can anyone help differentiate? Yes, go ahead.
I wanted to say, would it be 0.0545 t?
Careful, careful. So I'm not saying that this is incorrect, but I would just stick with a rule. E to a function prime is e to the function times the inner function prime. You can twist it if you want, but you may forget and you may say t, and that's not possible. So e to a function prime, it's e to the function times the function prime, which is this. I have to multiply these two numbers, the 20,000. That's how lazy people do it with the calculator. So I got 1090. So the correct final form, 1090, e to 0.0545 t. This is the derivative V prime of t, the rate of change of the value in the account per year. But now we want to find V prime of 7. I have to put this in the calculator. Let me do it like this so you can see better. So you can just put the derivative right here, 1090 e to 0.0545 t, and then it's already in there. It's right here. Just have to go to the second function for x equals 7, and we have 1596.28. 1596 0.28. Measurement unit, and what does it mean? Measurement unit, and what does it mean? First, the measurement unit, please. What is the measurement unit for this? And it cannot, so this was in dollars. If this is in dollars, this cannot be in dollars. It's a different function. Good, so what do I write? Measurement unit for this.
Dollars per year.
Of course, thank you so much, Sammy. Indeed, that is, and it's positive, which means at the end of the 7th year, the value in the account increased by 1,596.28 cents. Awesome. Moving on, let's talk about the log functions. Now, I have to caution you, this book, don't ask me why, only discusses this situation. Only base e to x or base e to a function. But this is not the only, these are not the only possibilities, right? We can have any base to a function, any base to x. They do not discuss this, so I'm not going to bother you with it. In the same way, we can have log in any base of x and log in any base of a function. But since the book does not present those, I'm not going to bother you with those. So we're going to learn how to differentiate natural log, and we're going to learn how to differentiate natural log of a function. So this is our next target, and this is the last section of 2.3. Of chapter 2, which is 2.3. We learn how to differentiate log functions. Okay, quite simple, not to be confused with another one that we talked about. Natural log prime is 1 over x. To be correct, I should write times the inner function prime. But I don't. Why I don't?
It's 1, it's redundant.
Excellent. Can anyone mimic, so forget about this for x, but can anyone mimic this for natural log of a function? Exactly what you see there. Can anyone invent it or come up with it?
1 over x.
Careful, it's not x. We're talking about f.
Oh. 1 over function
Yes?
times the inner function prime.
Yo! Finally, thank you, thank you, thank you. That was so good, thank you. You made me so proud. Okay, back, I'm sorry. Good, yes, 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 indeed. Awesome, good. That's it, that's all I had to say. Let's practice. And here it is. And page number, let me scroll, okay, 216. I heard times the inner function prime. I will sleep very well tonight. Very well. Okay, anything you want to work on? We practice how to differentiate natural log in different situations, with a product rule, with a quotient rule, with all sorts. Do not choose the absolute value just yet. I will explain the absolute value in a minute. And of course, as you see, we are coming back to the same thing over and over. Find the equation of the line, tangent to the graph, blah, 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 at x equals 3. So let's start.
We do 12.
Yes, let's start with 12. Which page am I on? I think I'm on 8, yes. Page 8, very good. You said 12, very good. Y equals natural log x to the 4th over 2. And this is my page 8. Okay, I'll stop sharing. Good, awesome. I look at this function and I see that it's natural log applied to a ratio. But this ratio is basically a polynomial function. If you remember, and I kindly ask you to remember this, this is just sand in our eyes. What do I mean by that? In certain situations, this is easier, but when we differentiate, we have to think in these terms. You can still think in these terms, but I think it's easier to realize that this is the same with this. So when we want to differentiate, remember, this is a function. We have natural log of a function. This is not natural log x. This is natural log of this function. So what do we write? How do we differentiate that? It's just the same formula. Let me put it up here. Right here. So it has to be 1 of the function over the function. 1 over the function times the inner function prime. Anyone? Can anyone give us this function prime?
Two x.
So we have 1/2 times,
4.
yes, times,
X.
yes,
So,
to the,
X to the third.
that's it,
To the third.
that's it. Awesome. So let's write it as is right now, so for everyone to see. Of course, I have to flip this. So I continue here. So I flip and I get 2 over x to the 4th times. I simplify these two. 2 times x to the 3rd. And yes, this is at the top, and this is in the denominator. I remove 3 from here and 3 from here. So the final answer is only 4 over x. That's it. That's the derivative of that function. Any questions on this first attempt? Okay, let's choose the next. And I would like to choose one of these. My turn to choose. I will choose 13. And you choose the next one. I like to look at a product and a ratio. So I like to look at something like x to the 6th times natural log, and also natural log over x to the 5th. So let's start with any of these. So y equals natural log 3x squared plus 2x minus 1. Perfect. Can anyone help with this? We want to find y prime. Of course, also denoted by dy by dx, the same thing. Anyone would like to try?
Is it like 3x squared plus 2x minus 1 times 6x plus 2?
So natural log of a function prime is 1 over the function times the function prime. I accept and I agree with this. But why do I have
So
to?
would it be 1 over 3x squared plus 2x minus 1
This is it.
times
6x plus 2. Good. You can rewrite it condensed as 6x plus 2 over 3x squared plus 2x minus 1, sorry. Yes, that's it. Nothing else. This is the formula for differentiating such a function. Okay, let's also choose a product and a quotient. Let's say natural log x over x to the 5th. Okay, that's my page 9.
Can we do number 20 after?
Yes. Well, let's just do 20 right now.
Thanks.
Sure. So h of x equals natural log of 2x to the 4th e to 3x multiplied by x squared plus x plus 1 to the 5th power. I will change the outside parentheses. They are nested parentheses, but I prefer brackets. It's easier to explain what's happening here. Well, we have the outside, which is natural log, and I have the inside, right? So this is natural log of a function. So when I differentiate natural log of a function, I have to have 1 over this whole thing times whatever this is prime. So first I'm going to copy it in the denominator, 2x to the 4th e to 3x times x squared plus x plus 1 to the 5th. But now I realize that this is a product. But the problem here is that this is a product of 3 functions. 1, 2, 3. We have not discussed the product of 3 functions, but I will give you the formula directly. I would not ask you to do something like that. But since we asked and we started it, I have to finish it. So here's the formula when we have f times g times h. The product of 3 functions. There is no need for this, but as I said, we started it, I have to finish it. So when we have a product of 3 functions, then we have f prime times g times h plus f times g prime times h plus f times g times h prime. So there are 3 products, same. In the first one is prime. In the second one is prime. And in the third one is prime. So it's going to be a long thing here. So I differentiate this, and I get 8x to the 3rd. And then I copy the other 2. E to 3x, x squared plus x plus 1 to the 5th, plus. I'm jumping over all this. I copy the first one, 2x to the 4th, and I differentiate e to 3x. But e to 3x is e to 3x times the inner function prime, which is 3, times the last one. And now I reach the last plus, in which I copy the first 2, 2x to the 4th e to 3x, and I differentiate the last one, which is 5, x squared plus x plus 1 to the 4th, times the inner function prime, 2x plus 1, and now I close the whole thing. This is a little bit extensive. I'm not interested in it, but I wanted to answer the question. So let me go back. Let me see where my video is.